Okay, so we are ready to start, right? You can hear me? Perfect. Thanks, everyone. So it's hard to see because of the light, but I see some of the dataspace enthusiasts and that want to learn about dataspaces, the concept, and what is happening in the Eclipse Foundation in regard of technology development. So my name is Markus Spiekermann, and I will guide you today to the topic of dataspaces. Actually, I will do a very, very brief introduction on myself. Then I will give you the foundations of dataspaces. So we will talk about the concept, what a dataspace is, what it is not. We will also talk about the underlying protocols, which is the key part of dataspaces, which we are working on right now together with the Eclipse Foundation. So you will get some details on that. Then I will point you to the concrete implementation project, which is the Eclipse Dataspace Components. And then I will highlight a little bit how you can use the EDC to build dataspaces on your own. So first of all, some sentences about me. So my name is Markus Spiekermann. I'm working on the topic of dataspaces already since 2016. So from the very beginning, when everything started with IDSA, the International Dataspace Association, I was already involved in that project, and this is why I'm also an IDSA ambassador. I'm currently working for Huawei and the dataspace team located in Munich, and developing products based on the EDC that we will get to know later on for the Huawei cloud. I really believe that dataspaces is one of the opportunities we have right now to change how data sharing is happening. And I hope that together today we get a better impression how we can achieve this. So what is a dataspace? Actually, it is not as many might think of. It is not the next data lake. A data space is not about collecting data that I can use for my next analytical approach or my, the new business insights that I have. It is a new pattern that can be used for sharing data. You're not talking about data space in the sense I am interpreting it. So let's be honest here, there are different concepts out there that are named data spaces. You will probably hear of data spaces when it comes to data analytics and data science. But it is important to differentiate. And today we are talking about a governance framework that brings trustworthiness into your data sharing experience. We are talking about a framework that enables you to use policies and attach those to the data sets that you are prepared, that you want to share with externals. Other than data architectures you may know, like data mesh, data fabric, these kind of things that are more or less concentrated on the internal data exchange. Here we are talking about sharing data with partners, with even competitors. And the data space concept here is something that can show you how you can do that in a decentralized fashion. So the data space concept is about autonomy. It is about that you are able to, declare the policies with whom and when you want to share your data. It is about decentralization of technical components, and it is about getting rid of intermediaries and actors in the middle that can influence how the data is shared and that might lower and decrease the trust that you have while sharing. So the data space overview that you can see here on this slide is very abstract, of course. But what you can see is the basic components and also the key topics that we are addressing with dataspaces. So the connector, for example, is one of the key components in the concept of a data space that is managing what is happening to the data. There's a cataloging part, which is about advertising. We will come to that. There is this contract management, which is very important because this is the topic where we are defining the policies, where we're negotiating with externals, and where we then can hand over to a data transfer that make use of these policies. Yeah. So this is the very, very broad and abstract overview, but just that you get a gut feeling what is addressed. So I talked about policies already, because policies more or less is the heart of a data space. You can define policies and attach such policies to the data assets, and the data space infrastructure and components will ensure that while sharing the data, those policies are obeyed. But there are different sets of policies, and there's a different scope and context for them. So for example, you have the basic access policies, which is just saying, so you're allowed to access the data based on some information. So I listed also some examples that you can use for a better understanding. So the initial policy, the most basic one, is the access policies. Then you have usage policies, which is about adding some more details on how you can use the data, for what purposes you can use the data. Then you also have these contractual agreements, because when you have policies, of course, it is about negotiating. So there needs to be an agreement on these policies, which is in a data space concept depicted by such contracts. And on the highest level, there is the membership policy. So a membership policy could, for example, be you are a participant of one specific data space. That might be a specific business model, that can be a domain-driven data space. But to participate in an environment, you can use these membership policies. So with that framework of being able to provide policy information, we need to make sure these policies are used in the data transfer and while we are discussing about the sharing. And this is done by the protocols. I introduced the protocols as the key concept of data spaces because this is what they are. And there are two very important protocols that I would like to highlight now. One is the Dataspace Protocol and the other is the Decentralized Claims Protocol. Let me also add, before getting into the Dataspace Protocol, that this is strongly related to what we are doing in the Eclipse Foundation. Within the Eclipse Foundation, we have the EDWG, the Eclipse Dataspace Working Group, which was initiated end of last year, and where we, together with a group of companies and dataspace enthusiasts, are working on clear specifications on a technical level for the protocols that are required to bring them to an international standard. Because this is at the end, when we want to, have an impact on such a topic like the data sharing, that you can't, just do on your own, where you have to align with so many different people. This is what we should aim for, and this is what we are doing in the Eclipse Foundation right now. So let's dig a little bit deeper into the Dataspace Protocol. When it comes to the data space, and if you have the overview graphic and the capabilities in mind, there are three main parts. One is the cataloging part. The second one is the negotiation. And the third one is the actual data transfer. The Dataspace Protocol manages these three parts. The catalog part, so see the Dataspace Protocol as an overview and an umbrella of three sub-protocols. The catalog protocol is managing how you can advertise your data. So what kind of data do you want? What kind of metadata can you add to the data to describe the asset? How can you attach the policies? That's the catalog part. The negotiation part is about the sequence flow of a negotiation. So what types of messages can I send to my counterpart to show him or to align on these policies, the access policies, the usage policies, to come up with a concrete contract and a concrete agreement. This is part of the negotiation protocol. And then the transfer protocol, which is about not directly share the data. I forgot to say that on the first slide. So in a dataspace, the actual data, the used data, is not shared by the dataspace components itself. But the components make sure that through these protocols, the data transfer actually and the sequence is managed to hand over to data planes that actually moves the bits. Yeah? So there could be a lot of data planes. The protocol is for initiating the transfer, make sure everything is in place, and then hand over to an existing data plane. So the current status is, as I said, the protocol specification, the first version is available with the 2024-1 version, which was initially developed by the International Dataspace Association and was then contributed to the Eclipse Foundation. Yeah, so there is a specification project under the umbrella of the Eclipse Dataspace Working Group, where every one of us can support and contribute to build such a protocol. It is based on available, established standards itself. So for the cataloging part, we are using DCAT as an example. For defining and formalizing policies, we are setting on top of ODRL, which is the expression language to put that into text. Beside the dataspace protocols, so cataloging, the negotiation and the transfer, we need to manage identities within a dataspace because, so for building trust, having these claims, having these identity managed is also one of the key aspects. The Decentralized Claims Protocol is aiming on that. It is also a specification project under the umbrella of the Eclipse Dataspace Working Group. And it deals with two main parts. It is about the issuance of claims. So I, as a company, can claim everything, right? But it is important to know how these issued claims can be verified. And issuance flow is one of the most important aspects here. The second one is then how I can present these claims to others, and how the sequence look like, how this is done. And this is also addressed within this Decentralized Claims Protocol, DCP. So also here we have something on top of established systems like the verifiable credential and verifiable presentation and DIT, Decentralized Identifier Document System. But again, we are specifying the concrete message types, we are specifying the concrete sequences, and also how the API bindings look like. To form a protocol, to specify the protocol that can then be used for international standardization and can be used for such, to implement such components and concepts like the dataspace. And this is what we are doing within the Eclipse Foundation in the Eclipse Dataspace Framework and the Eclipse Dataspace Components project. So the Eclipse Dataspace Components project, EDC, is about building a framework to enable companies to build their own dataspace components. The project is not about giving you a software that you can just download and run and participating and you can participate in a dataspace. Because we will see so much different dataspaces out there. We will see so much individual requirements for specific business models, for specific domains, that there is no this one-size-fits-all solution. But what we see, and this is why we also strongly leverage the open source community here, is that there are some parts that are always the same. Which is, of course, having a software stack that can be extended, a software stack that is modular, a software stack that makes use of the protocols I discussed before and that are compliant to the concepts of a dataspace, so that there's decentralized architecture. There is, no need of a man in the middle for your data sharing. That there is no data flow directly through the components. So this is what we can ensure already with software, and this is what we are enabling with the Eclipse Dataspace components. So we have a strong community. You see some of the contributors on the right. We started this project in 2021. So we already have components available that can be used, that can be adopted by various projects, and we already see a lot of adoption going on already, also in a lot of dataspace projects. So you may heard about Catena-X, for example. You may heard about Iona-X as one of the tourism dataspaces. You may have heard about agriculture data sharing. So they are all based on the EDC framework, but they are not just using EDC. They're using the framework and add their own extensions and add their own customizations. And this is very important to understand. And this is what makes EDC special, because there are 3 guidelines. Yeah? The EDC wants to serve a broad range of use cases. As I said, one size fits all, it won't happen in dataspaces. Yeah? Think about how you can exchange data and how many possible ways of sharing, of exchanging data is out there. You have streaming, you have big data, you have small data you can just push via FTP or other protocols, right? So we have to support multiple use cases. We also don't have to and shouldn't reinvent the wheel, because data exchange in itself is solved, right? And no company will now install and use technology for data sharing, and completely drop everything that is already used and optimized in their infrastructure. So companies have already technologies like Kafka for having their event-based system up and running and share streaming information, for example. So let's just reuse what is there. So that was also one of the key guidelines and principles when we set up the EDC project. The third one is, I'm repeating here myself, but it is so important that we want to base on available standards and not just saying that we are, creating our own standards. We hear that sometimes. We want to base on the international standard that are formally specified and formally set up within the ISO and within the Eclipse Foundation to be contributed as a pass to ISO. So, I already said some sentences to that, but let me again repeat to make this very clear what the EDC is not. The EDC is not something that you can download and use within your Dataspace project. But the EDC will help you build your own components. We are not, agnostic to one infrastructure. So this project is not just running on Azure. This is not just running on AWS, and it's not just running on Huawei Cloud. The EDC is built to run infrastructure agnostic, and you can build extensions to the technologies of your, favorite cloud ecosystem. And the use case stuff that we already discussed. So, and make this EDC modular and make it extensible, we have these kind of architecture principles. So it's modular, it's resilient, so it is defined that when there is a data plane crashing, that there are other data planes that can put up the work, that it is, the resiliency also comes from the software is provided as much in favor of, being error prone, or not error prone, to make it very stable. Yeah, make it extensible also means there are very clear interfaces that you can use. So the framework, what the framework provides is a clear set of interfaces that developers of, for example, these data sharing technologies, but also, for example, persistence and storage systems can use to integrate their solutions into Dataspaces and into the EDC. And this is done by the EDC's extension mechanism, which is built on Java SPI, so the service provisioning interface, and where you can plug in your extensions into the core modules of the EDC. So the core modules of the framework provide the basic capabilities, supporting the protocols as one example, providing the service management, providing registry capabilities of data for data planes, so you don't have to care about that, but you can take care of the business logic. You can take care of using the technology that you want to use within Dataspaces for sharing data, for managing your data internally, etc. This is the key of this extensibility of EDC. Let me formulate another thing. So, of course, you don't need to implement everything on your own. There is also another reason why we choose the open source community, because there is so much great open source work out there, projects, etc., that are used. And of course, it makes sense for such established systems to provide extensions already that can be used for plug and play. And so there will be situations where you can, have a toolbox of the EDC as its core and available extensions and just plug them in and use them. But you still have the choice to add additional ones and customize the components on your own. Yeah. And we see that on the technology level already. So for example, in the Eclipse Dataspace Components in the project on GitHub, you see extensions provided by Google. You see extensions, so BigQuery, for example. You see AWS providing extensions for S3. You see Huawei Cloud providing an extensions for OBS and Azure for its blob storage. Yeah. Of course, you can reuse this, but still, for your impression, always there is the way and the possibility to customize. And to give you also an overview about what components are available. So it is, there's a reason why it is called Eclipse Dataspace Components. The core of the EDC also is divided into 4 different main components, which is the control plane. The control plane of the EDC is the brain of the EDC framework, and it is responsible for the negotiation part, to instantiate the data flows, to get the agreements, make sure that everything is stored consistently, etc., and then hand over to a component called data plane. And this data plane is then the data sharing, data exchange technology itself that is moving the bits. So there we have all these BigQueries, OBS, Kafka implementations, but this is kind of dumb. So it is really just about exchanging the data, how the technology is already doing it right now. It can take care of these policies because the control plane is still while handing over monitoring what is happening. It can, interfere with when there is something, happening what shouldn't happen. So this is still then part of the flow, but the data plane itself is just about exchanging the data in a private channel. The control plane, beside monitoring the data exchange, also is connected to the catalog, which is the federated catalog called in EDC, and which is about the data assets advertisement. So in the catalog part, there is, there's a crawler mechanism that makes sure that the data assets from all the participants in a data space are visible. There is a caching mechanism, of course, in terms of reliability and scalability as our core architecture principles. But the catalog is about managing data assets. So this is, how you can think about it. And it makes use of the Dataspace Protocol's catalog part, as you could imagine. And then, last but not least, there is the Identity Hub. And the Identity Hub is about decentralized management of the identities, making use of the Decentralized Claims Protocol, and where you can manage the verifiable credentials, verifiable presentations, how you can present claims to other participants within a data space. So this is happening through the Identity Hub, which is then sharing tokens with the control plane again, with the brain of the actual transfer for the participant. And so the control plane can use these identities and these tokens within the whole process. So this is, so to say, the overview from the component level. And with all these 4 components in place, there are, some other optional ones, like, you could imagine a user interface for the connector, where we have a stub implementation available. But those are the 4 core components that I want to highlight today. And with those components ready and at your fingertips, you can start building data spaces, actually. Because this is what you need. Having this EDC components, having the data planes, the extensions that are available, or you build your own, and then you can design and build your own data spaces on top of that. We are supporting those activities with a set of samples. So this is to get the hands on the EDC project, to get some insights into the basic principles that I was referring to get some hands-on experience on how the protocols are handled, these kind of things. Writing your first own extension, this is part of the samples repository. But we are also providing a minimum viable data space, which is a basic configuration, not for productive usage. Short disclaimer here, because this is often misunderstood. It is for showcasing how a data space at the end could look like, with all the customization, with the extensions in place, but with a working, setup of different connectors. There are different catalogs in different configurations available that you can have a look on. There is the Identity Hub running and managing credentials as it is supposed to be in the data space in this decentralized fashion. And also there is, of course, the data exchange, and you can follow how this is done through the control plane, through the handover, then the actual exchange to the data plane. So if you want to get your hands on data spaces, I would recommend you to start on this repositories, because this is actually what you can use on the technical side as a very good starting point. Also, of course, I would highly recommend and request that you all are more than welcome to contribute to the EDC project, but also in the Eclipse Dataspace Working Group. Within the Eclipse Foundation, because there we are, as I said, discussing the concepts, we are discussing the technical concepts, we are discussing the protocols and the specifications on a technical level, and everyone that can bring in their expertise is very, very valuable, and we are looking forward to that. With that being said, thanks for your time, and if there are any questions, please let me know. Thank you. So, are there any questions? Or some topics where I can go into details?
Does the EDC work with other implementations of the IDSA specs? Like, if there are others?
It depends. Yes, good question. It depends on. Actually, it depends on the version of the IDSA concepts that you are referring to, because there was a shift, right? So since 2016, a lot of things happened already in the data space field. And also in the concept, there was a shift through to more decentralization, and also that the focus on interoperability is more on this protocol level. And this is why I also emphasize this protocol level here in this talk. First, because it's also an Eclipse Foundation activity, but also because this enables us to have everything interoperable, and also the other connectors. And I know that some other connectors also are working on bringing the Dataspace Protocol and the Decentralized Claims Protocol into their connector implementations. Then we would be interoperable. If there are some legacy components out there and connectors, then I have to say no, and EDC will also not work on getting interoperable with them, because we focus completely on the standardization activities.
Thank you. What is in your opinion, one of the next steps or biggest trends for the near future or far future of the EDC or Dataspaces in general?
So that it's also a good question, and this depends on your the perspective that you are coming from. So if you are a company that wants to use Dataspaces, it is about getting an understanding of the concepts, have a look what is already available from the framework, but also adopting downstream projects. So just to give you an example here without advertising, so there's a Tractus X project which is completely based on the EDC framework, but which is a software component that can be downloaded and used in specific use cases for the automotive domain. But when you want to adopt Dataspaces, this is the next step you should go for. If you want to contribute to Dataspace technologies, I would say the next steps are the ones that I have on my slides, so the samples and the MVD, to get a feeling of the source code that is available. If you want to bring in new ideas, if you see that the concept is maybe not mature enough and there is something missing, then I would like to point you to that guy in this blue pullover on the back, because that's Javier, and he is the project lead of the Eclipse Dataspace Working Group, and the best contact person also for the next 2 days here, if you want to get more information about the Eclipse Foundation's work on that. So maybe if we have 3 minutes, so another thing from the research perspective, maybe that's another interesting point to come, right? So there is a lot of innovation as well in Dataspaces because you have this decentralization approach. So managing data in a decentralized fashion is always challenging. So there are a lot of challenges that we need to overcome. The same is true for this identity management. Yeah, so we have these, the Decentralized Claims Protocol, actually. It is, you know, we often hear there is something always or already available with OpenID Connect, for example, yeah, or IDC. But at the end, so while we are doing our research on these protocol levels, we found out or we identified gaps that we need to close. So for in this example, it is about really managing industrial data and company as the identity without, so you know, the personal layer. Yeah, so I don't want in a data space, I don't want to have usually on my smartphone a wallet application where I need to scan a QR code. So that's not a data flow, yeah, or a sequence that can be used in such industrial and enterprise environments. So there's also a lot of, I think, interesting work you can think of from a research perspective. Do we have other questions? Does not seem to be the case. Then again, thank you, and it was a pleasure. Thanks.